Welcome to a slow, beginner-friendly lesson on dictionaries, create and look up, made for absolute beginners. Let's begin. Today you meet the most useful collection in Python, the dictionary. A dictionary stores pairs, a key on the left, a value on the right. You look things up by name, not by position. If a list is a row of shelves numbered from 0, a dictionary is a phone book, you give a name, you get back a value. In this lesson you learn how to create a dictionary, how to read a value by its key, how to add new keys, how to remove keys, and how to walk through everything inside. We go slow, one idea at a time. The most useful collection. Think about a contact app. You want to find someone's email. With a list, you would have to remember the position, is email at index 2, or 3. With a dictionary, you just ask by name, person square brackets email. The key is a name you choose. The value is whatever sits behind that name. No counting, no order to remember. Dictionaries exist because most real data is named, not numbered. A person has a name, an age, an email, each one a key. Named, not numbered. Until now you reached values by position, index 0, index 1. That works for simple lists. But most data in the real world is named. A person has a name, an age, a city. You want to reach those values by their names, not by counting. That is what a dictionary gives you, a way to look something up by name. From counting to naming. The simplest dictionary is an empty one. You write open curly brace, close curly brace, and you have an empty dict. Type of person gives dict. Len of person gives 0, there is nothing inside yet. Empty dictionaries are useful when you want to start fresh and add keys as your program runs. You can also create an empty dict with the dict function, which you see next. Start empty when you need to. This is the most common way to create a dictionary, curly braces with key value pairs inside. The key comes first, then a colon, then the value. Pairs are separated by commas. The key name points to Ada. The key age points to 36. The key city points to London. Notice the keys are strings, and the values can be any type, here a string and a number. You choose the keys, they are the names your data is filed under. Curly braces hold your pairs. You can also build a dictionary using the dict function. You pass keyword arguments, name equals Ada, age equals 36, and Python builds a dictionary from them. Notice the result looks the same as the literal version, string keys, the values you gave. The dict function is convenient when your keys are simple valid identifiers, but it does not work for keys with spaces or special characters. For those, use the curly brace form. 2 ways to start. When you write person square brackets name, here is what happens. Python takes the key, the string name, and searches the dictionary for a matching pair. When it finds the pair whose key is name, it returns the paired value, here, Ada. Think of it as asking a question, what value sits behind the key name? The dictionary answers. No counting from 0, no scanning a long row. 1 key in, 1 value out. That is the lookup model. Ask, and the dict answers. A phone book works the same way. You do not flip through pages counting 1, 2, 3. You jump straight to a name, and the number is right there. A dictionary is your code's phone book. Give it a key, get back a value. Fast, direct, by name. A phone book in code. To read a value out of a dictionary, you write the dict name, then square brackets, then the key. Person square brackets name returns Ada. Person square brackets age returns 36. The key goes inside the brackets, and you get back whatever value is paired with that key. This is the everyday move you will repeat thousands of times. Look up a value by its key, using square brackets. Square brackets, every day. What happens if you ask for a key that does not exist? Python raises key error. Here we ask for person square brackets email, but the dict only has name. There is no email key, so Python stops and tells you, key error email. This is important. Direct lookup with square brackets assumes the key is there. If it might be missing, you should use a safer way. That safer way is called get, and you meet it next. Missing keys are loud. The safer way to look up a key is the get method. Person.get email, notice, no square brackets, no error. If the key is missing, get returns none by default instead of raising key error. None is Python's way of saying nothing here. You can print it to see it. Get is what you use when you are not sure a key exists, when the data is incomplete, or when missing keys are normal, not a bug. Get is gentle. Get takes a second argument, a default value to return if the key is missing. Person.get email, no email. The key email is not in the dict, so get returns your default, the string no email. If the key were present, you would get the real value instead. Defaults make your code graceful. Instead of crashing on missing data, You get a sensible fallback that you choose. Choose your fallback. Real data is messy. Keys you expect are sometimes absent. A good program does not crash, it handles the gap gracefully. The get method is one small tool that makes your code calm under uncertainty. You will reach for it often. Handle the gaps. Dictionaries are changeable, you can grow them. To add a new key, you write == email equals a value. If the key does not exist yet, Python creates the pair for you. After this, person contains name and email. The new pair appears at the end of the dict. You did not need to declare it ahead of time, assignment to a fresh key just adds it. That freedom is part of what makes dicts so handy. Grow it as you go. What if the key already exists? Assignment overwrites the old value. =name equals Ada Lovelace, and now the name key points to the new string, Ada Lovelace. The old value is gone. Adding a new key and updating an existing one use the exact same syntax, square brackets and equals. Python decides, if the key is new, add it, if the key exists, replace its value. Same move, new value. To remove a key value pair, you use the del statement, short for delete. Del =age removes the age key and its value from the dict. After that, person only has name. The pair is gone completely, not just hidden, deleted. If you try to delete a key that is not there, Python raises key error. So always be sure the key exists before you delete it. Remove cleanly. Before you look up or delete a key, you might want to check whether it exists. The in keyword does that. Name in person returns true, because the name key is there. Email in person returns false, because email is not a key. Notice, in checks the keys, not the values. This is a fast operation on dicts. Python does not scan every pair, it jumps straight to the answer. Check before you trust. Every dictionary can show you all its keys. Person.keys returns a view of all the keys, here name and age. We call it a view because it is not a real list, but it behaves like one when you loop over it. The order matches the order in which the keys were added. When you need to walk through every key in a dict, for example, to print them, keys is what you reach for. See every name. Person.values returns a view of all the values, here Ada and 36. The order matches the keys, the first value belongs to the first key, the second value to the second key. Values is useful when you only care about what is stored, not about the names. For example, if you had a dict of student scores and wanted the average, you would walk through values. See every stored value. Person.items gives you both at once, each pair as a small tuple. You see name, Ada, then age, 36. Items is the tool you use when you need both the key and the value at the same time. It is the most common way to walk through a dictionary in a loop. For each pair, you have the name and the value side by side, ready to use. Both at once. Dictionary values can themselves be dictionaries. Here the address key points to another dict, with city London and zip NW1. This nesting is how you model structured data, a person who has an address, which itself has a city and a zip. The outer key address gives you the inner dict, which you can then look inside. Real-world data from APIs and databases almost always looks like this. Dicts inside dicts. To reach a value inside a nested dict, you chain the lookups. Person=address gives you the inner dict. Then *city on that gives London. Read it left to right, first lookup address, then on that result lookup city. Each pair of square brackets is one lookup. Nesting lets you model real objects, a person, with an address, with a city, and reach any leaf value directly. Chain the brackets. If you want to lock this in, try a small exercise. Create a book dict with a title and a year. Add an author key. Look up an ISBN with the default. Check whether title is a key. These 4 moves cover most of what you do with dicts every day: create, add, look up safely, and check membership. When these feel natural, dictionaries are yours. 4 moves, every day. A dictionary stores key-value pairs. You look up a value by its key using square brackets. When a key might be missing, you use get with the default. You add a key by assigning to it, you remove one with del. You check membership within. And you walk through the contents with keys, values, and items. That is the everyday toolkit. Practice these moves until they feel automatic. Hold the toolkit. Next you learn how to loop through a dictionary using a for loop, walking through keys, values, or pairs one at a time. Then you meet patterns like counting with dicts, building dicts from data, and merging 2 dicts together. After that, we slow down on sets, the unique items collection, and tuples, the fixed, unchangeable record type. The collection's journey continues, one atom at a time. Looping is next. Thanks for learning how to create and look up dictionaries. Next we loop through them with 4. See you in the next lesson.